Hello, welcome to another Great Cow Basic training session. Today we're going to be looking at I've already recorded it once at 22 minutes. No good. Right, next. We have a pick. It's connected to a pick kit 2. It's a 18 16F 18313. It looks like this. Move on. Okay, what are we going to be doing today? We are going to be flashing this LED. This LED is connected into here, and inside of here we're going to be using Timer0. Chris Roper designed this board, and it emulates a microchip low pin count board on an 8-pin chip. Okay, so we're going to set up a timer, and when that timer event occurs, we will toggle the timer. Okay, now there's a lot of research you can do on this. It is a nightmare. Okay, I went to the web trying to find different resources, and luckily a few years ago I came across a spreadsheet that does it all for me, okay? And I'm going to share that spreadsheet as part of this training. But remember, it's pretty hard, okay? So there are 4 things that we're going to have to do. One is we're going to have to initialize the timer, okay? We're going to have to tell it what the clock source is, whether it's internal or external. Then we're going to have to set up some mathematics in terms of prescalers and postscalers, and then a clock source. And that clock source basically tells us where it's coming from. We already told it it's internal or external. And if it's internal, we just need to remind it what it is. We then need to set the timer. We have to give it a value, and when that value matches another value, then it will raise the event for us. So we have to calculate that, and believe it or not, it's quite hard to do that. Then we need to start the timer, and then we can clear the timer. So there's 4 things we need to do. There's another thing you need to do when you've got a timer running. You need to clear the interrupt flag or that bit, and we are going to be doing that as well. So what are we looking at here? This is a piece from the data sheet, very clear. We've got to tell the this Timer0, as I stated before, a number of things. We have to set what the clock source is, and that's one of these. Remember, all these clock sources have got very rapid little square waves like that, okay, a wave. We need to set something called the prescaler. We need to set something called the postscaler, okay, to get a signal out of this end here that matches our requirements. And if we're going to go for let's just think of it, a 1 second pulse, when this is 32,000 megahertz up here, how do we turn a 32 megahertz signal into here is by doing some mathematics via the prescaler and mathematics of the postscaler. Now, you can go to the web and try and research this, and I was unable to find anything. I looked today and I still can't find anything. If I show you my desktop, you can go to the web, you can find a really good timer tutorial, but it doesn't refer to these newer chips, okay? You can find some generators, but they don't refer to the newer chips. They only refer to, and you'll soon know the problem, is if they only refer to the prescaler, you know it's a problem. You can go to, I tell you what, I put inside of our build, you've got a zip file that's inside of this a folder, and in here there's a load of tools that do calculations, and none of those work. So we need a way of setting up the prescaler and the postscaler, okay, and without having complex mathematics and making it pretty simple. So what we've got quite easily, we've got a calculator. This calculator is based upon a spreadsheet, and that spreadsheet initially does only the prescale version, but I've added in a few years ago. I've had this for years in reality. I've added in this enhanced 8-bit timer piece, which is what we're doing today. Okay, all right. And essentially, what we're going to be doing is telling it some parameters: the chip megahertz, the prescaler value, whether we're using a clock divider, which we're not, the postscaler, and the time that we want. So if we know certain things, because we've always been using, we're going to use 32 megahertz, and if we want a time of 1 second down here, because it's in seconds, I'm going to have to set up a prescaler, because it's calculated it for me, of 16,384 and a postscaler of 11. Now, if these parameters were incorrect, this goes red. And essentially, you need to get it in a range. I am not going to go into the details of postscalers and prescalers, okay? I'm going to tell you how to set it up, and that's it. If you want to have a pulse every minute, every second, then you can change the frequency. That's one way of doing it. You can change the prescaler, you can change the clock divider, or you can change the postscaler. But essentially, it kicks out a number at the bottom. Okay, so for a 1 second pulse, if I choose 11 in here, I like 11. I'll use 1634 in here. I'm going to put that into my program. So these are the parameters that I'll be using. So what I've done is I've set up the standard header here with one LED. Okay, and in here I put this code. So I am going to, stick this code down here, and I'm going to take away all these silly numbers at the top, okay, all right? And it's the same 4 steps, okay? Don't need that. So let me just go through it for you, okay? Clock source, we can use internal or external. We're using internal, so we put the word oscillator in here. The prescaler, and I'll zoom in on this in a moment. Let me just do this for you. Oh, is that better? If I zoom in on that, now this editor doesn't let me zoom in, does it? That's unfortunate. Oh, I know a way of doing it. No, I don't. Clock megahertz is 32, confirmed. That's up the top here in the editor. I need a prescaler of 1634. So you don't just put that in here. You can't just put 1634 in there, because that's not how it works. We need to give it a value, and what we're going to do is very quickly get that value from the help. And if we go into the help, there's it for this particular help. I've got the value here. Like, look, I need a value of this. Well, you can put 14. I don't care which one you use. These are constant. Look, we'll use that constant. We're going to put that in here, and that's our prescaler. All right. Our clock source. Okay. I need to get that some clues from the help. And our clock sources, where are they listed? Could it be any of these? And that was in that diagram in PowerPoint we were looking at. We're using an internal one. Okay. And this is a one-to-one relationship. So I'm going to put that in my source code. And my postscaler, I'm trying to remember what the constant is, but I can't. My postscaler is 11. That's the prescaler. The postscaler of 11, the constant is post 11. And I'm going to put that in my source code and paste it in there. So I've taken this line here. Let me zoom in for you. I've taken this line. I set the source to the internal oscillator. I've set the prescaler to my calculated value in my spreadsheet, and my postscaler in here. So what do I need to set it to? I'm just going to drop back into the PowerPoint, the spreadsheet, because I can't remember it. This number here, click on it and just copy it into here. I'm just going to put that value in here, and then I'm going to start the timer. these are the 3 things I need to do. Now there were 4 in PowerPoint. And the 4th thing was clear the timer optionally. Okay, yeah, very good point. All right, let's do a do loop. Let's get this done very quickly for you. Oh, I don't like that. So, what's the event called? Unfortunately, we're going to have to go to the data sheet. So if we go to the data sheet, we can have a look. If we look in the data sheet on my desktop, one moment, that's a COVID cough. If we look in the data sheet, it says here the interrupt flag is set when the following occurs. And well, we're doing this, so that's the flag. We take a copy of that and we're going to put that into our source program. Wait while, if it's been set, if it's been set, we can set it like this lot. We can say wait here whilst that has not been set. Is set equal to 0? Well, the moment it is set equals to not equal to 1, I'm going to set LED1 to not LED1, so I'll flash the LED, and then I am going to clear this flag. All right, I need to clear the flag. We go back to the data sheet for a second. It says in here, it will say in here that you need to, in general, will be set. Oh, there you go. This flag will be set when it rolls over or it matches. So you have to clear it because it's a flag. Okay. So our code is very, very simple. It's set up the timer. We can clear it if we want to, but we don't have to. But we must clear the flag at some point, otherwise the event will never happen again. Let's compile that up. Oh, I need to tell it which timer. Oh, yep, there we go. It's Timer0 because it did say I need to put that in here for us. Okay. There's a timer number missing in there. Okay. F5, just compile it up and put it in that chip. Let's have a look what's happening on down here. Nothing. We've got a signal. I've got an oscilloscope and it's capturing that, but the scale on that is a little bit too big. Okay, so back to my desktop, I'll go into Excel and I'm going to change the value in here, and I'm going to change that to about 10 milliseconds, right? Okay. And I put that's 10 milliseconds because it says it here. Look, I need to put a value of hex 0, well, hex 100. Okay. Back into my source code. I'm just going to change that to what I want. I'm going to flash it. I just changed the source code in there. I'm going to the desktop. I just changed that source there to 100 into the. Oh, what's happening here, eh? Oh, look at that, brilliant. Let's just turn that trace off. What's the scale here? The scale is 10 milliseconds. That's 10 milliseconds, each horizontal graduation. What's the value in the spreadsheet? 10 milliseconds. If I change that to 0.0, I don't know, I can put it to anything really. 0.04, it'll be 400 milliseconds. Now, if I try to put in there a stupid value like 5 seconds, it will go red. That's because the tool in here, you can't get, there is no way you can get 5 seconds. You'll have to do other mathematics on it. The maximum time that the maximum you can get out of a chip using prescaler and postscalers is what, 4.5 seconds? Oh, no, yeah, 4.2 seconds, I think, from my 4.1. But guessing, yeah, 4.1 seconds. But that's not too bad. It's not too shabby. But you won't be doing that, okay, will we? So if we wanted a strange value, one, 200 milliseconds. You can calculate this stuff by hand. You don't need to have that spreadsheet, to be honest. Okay, all right. I'm just changing that value in there to C00. And it's because that these are quite round numbers. We will change that frequency, and we're now getting an output signal, a square wave, meeting our requirements. Let's change that. I like it, so it's like that. That is set to 0.1. What was in the spreadsheet? It's every 200 milliseconds, so that's correct. C00 in our source, C00. Prescaler is actually not set to that. That's why it's wrong. Look, prescaler. It should be 1800 for that particular prescaler. Just programming it. Now that's better. We've got something that is more meaningful. Okay, there we go. All right. So what I wanted to show you today is how to set up a timer. It is a mystery. It is harder. We're now at 16 minutes, so we'll give it a break. I've set up the LED. I've initialized the timer. I've set the timer, started that timer, and then a small amount of work down here is just to say, has that event occurred? Has it timed out? And the beauty is, you've got a calculator that does it for you. Or you can do your own research and try and work this out on your own, but it's extremely hard. And with that, we're going to call this session done because we have created timers using prescalers, postscalers, and clock sources.